Now let's see how we'd solve for the equation of an exponential function, given that it passes through a couple of points. So let's say you're given that there's an exponential function and it passes through the points 1, 5 and 4, 10. So let's say you know that. Well, how do you then find the equation, the y equals b a to the x, that passes through both of those points, right? And it's the same percentage change every time period. So one way to do it, and there's a couple, the way that I personally usually like to do it is, well, for any given point, let's take this first point, 1, 5. You could basically plug this 1, 5 point in for x and y. And you could do the same with the other point, the 4, 10, right? That's basically what you have. You have 1, 5 and 4, 10. Let's plug in that first point. Notice that the y is 5. So 5 equals b, a. Those are the things we got to solve for. And then x is 1. So that's b a to the 1. And in the second equation, the y is 10. So again, using y equals b a to the x, if we plug in for the x and the y is 10. And then b a to the power of x, which is 4. Now, the procedure I always use to solve is in the first point, solve for b. So here's first of all the big picture that's going on here. There's two equations, this red one and the blue one, and there's two unknowns. There's a and b. Once you have a and b, you've done the problem. That's really our goal. Eye on the prize. What's the a and what's the b? So really, what you can do is, in the first equation, you can solve for one of them. Let's solve. So usually what I personally do is I solve for b in the first equation. And let's see what happens when you do that. A to the first power is just a. So if you divide both sides by a, your right-hand side is just left with b, right? Because you divided out the a. And the left-hand side is just left with 5 over a. So now you have what your b is. It's 5 over a. Now you can just plug that in to the second equation, the b in the second equation. So let's rewrite the second equation. 10 equals b, which we know is 5 over a, right, from the first guy, b a to the 4th. And now in this equation, we could simplify this because the a's can cancel, right? There's an a on the bottom, an a to the 4th in the numerator. So that can cancel. You're an expert at this point on the exponent rules, right? A to the 4th divided by a, that's 4 minus the exponent of 1 here. So you just have an a cubed there. And you also have this 5, of course. So it's 5a cubed, and this is 10. So now we could just solve for that a. Divide both sides by 5, and this just becomes 2 on the left, and the 5's cancel, so just a cubed. And then finally, you could take the cube root of both sides. So that's the cube root of 2 equals a, which of course you could write, depending on the answer choices, you could write as 2 to the 1/3 power equals a, right? So we got that. Now, and again, if you're allowed to give answers in decimals, depending on your goal, you could just pop that into a calculator and get a number for it. But if not, we have this, and now you could plug this back in to the b that you solved for. B is 5 over a. So b is 5 over a, which is 2 to the 1/3. So there you have it. You got your b, you got your a. So your final answer is y equals b, which is 5 over 2 to the 1/3, a, which is 2 to the 1/3, x, right? So y equals b a to the x. So that would be your answer.